Welcome again to the DS Incubator. We are still on the series about cloud computing, and today we're going to be talking about more ways to move data. Last time we talked about moving data in a kind of special way with basically using GitHub as an interface, like moving data from whatever you have, either a server itself or a container running inside that server, and then moving it to GitHub, and then from there you can move it to your local computer. So using GitHub as an intermediary, and I advertise the GH CLI, the GH command line interface, because I use it a lot and I think it's awesome as a way to move data to GitHub very easily with GitHub releases. But today we're going to be talking about actually more common ways to move data around and more kind of straightforward. The first idea is the simplest, is the idea of moving data from your computer to a server, to a remote computer. In this case, it's going to be a Digitalocean Droplet on the cloud. It could be any remote computer. And then we're going to be talking about the idea of moving data between containers and between the server and containers. We have been touching on that idea. We used already volumes, which is the tool that I'm going to be demonstrating today, Docker volumes, but we have not talked about one flavor of Docker volumes, that is the idea of named volumes that are not managed kind of by you, I manage automatically by Docker. So I'm going to explain that in a bit. So let's get started. Going to the folder of today's meetup, which is number 5, more ways to move data. So let me expand, actually move this to a side and open a little terminal here. And there we go. Let's make this a little bigger. And this a little bigger too. Okay. So first, everything I'm going to be demonstrating today requires that you have a connection via SSH between your local computer and a remote computer. In here, I'm working with Digitalocean Droplets as a server, so that's what I'm going to be demonstrating. So how you create that connection via SSH, I think I demonstrated it a few meetups ago, but basically there are a couple of resources that I'm going to show at the very end, and also this link here. If you have an account already, you will see something like this. So let me show you what it looks like. I already have an account in DigitalOcean, and in the account security, you have a link to add SSH key. So that is how you would create an SSH key. There are instructions here. They are not super long, not super hard, but you can serve yourself to creating that connection that you will need. So now I'm going to assume that we do already have an SSH key that is going to be the link between our local computer and the remote computer. So the very first thing I would like to do is to create some fake data on my computer. So this is what I'm going to be doing, basically. In my local computer, I'm going to make a directory. In the temporary directory, I'm going to create another directory. It's called data. So the temp directory already exists in my computer, but data doesn't, so I'm going to create it right now. And now I'm going to change directory to that temp and show you that if I do an ls on data, the directory exists, it's just that it is empty. So I'm going to couch some data. I'm going to create a data set called a.csv and a data set called b.csv. So if I do an ls on data now, you should see them there, right? So that's the beginning. So we have some data in our local computer, and we would like to move it to a remote computer. So let's then open another terminal here where I'm going to be connecting to my remote server. So this is how I would connect. And if this looks odd to you, let me break that down for a second. SSH is just a command line tool that allows you to say, okay, who is the user that's going to connect to a server? So in this case, the user is going to be root. And you have to then say the address of that remote computer. So the address comes from here. So if you already have an account on DigitalOcean, for example, you would have the ability to create projects, and inside those projects you would be able to create droplets, which are no more and no less than computers running on a remote server. So here I have one already. This is the name of it. It's a little weird name, Docker Ubuntu blah blah blah. So this is the number that I have been using every single meetup, the one that you need to find that server on the cloud. So that number is what I'm gonna stick here, right? So that's the number that you see here. Is the address of that remote computer on the internet right now. So I'm gonna execute that by running, by pressing enter, and all this text just confirms that I have effectively logged in. I'm gonna press Ctrl L to clear that up, and I'm gonna go back to my notes here and move them again to my right, so we can follow them. So we already have then some data on my local computer. We already have a connection on a remote server. So I'm gonna be talking between these two computers, right? So these are the two computers. So the one here on the left on green is my local computer, and the one here on the right is my my server. So let's go back to my notes. So the first thing we want to do is, remember we created a data folder inside my local computer. So we're going to copy that data to the server. So let me break this down. So we're going to be, of course, using the address of our remote computer, right? Because that's the destination of the data that we want to copy. Usually, if you are used to the terminal, you could type something like copy some file to somewhere else. Now, the file that we want to copy is the one, or the folder we want to copy is data, right? And because we want to copy all files, we have to say that it is recursive copy. But copy itself won't do it. We need scopy. That is secure copy. That is what uses the SSH key to actually copy the data. So this is how I'm kind of slowly building the command. So we securely copy recursively the data folder and all its contents as the user root at the address given here. And then we have to say where we want to copy it. So the address is so far the address of the computer itself. But now we have to say where in that computer we want the data to land. So I'm going to say column /tmp. So I'm going to copy data to the tmp directory inside the remote server, right? And that tmp folder always exists in a Linux system, so I'm confident that it exists. So I'm going to run enter here. And that should do the trick. I'm going to take a little second, and it's telling me the process. So A has been copied and B has been copied. So now if I go, so remember this terminal in green is my local computer. So if I go to the other computer, the one on the server here, if I do an ls on tmp data, I should see those files. So I have effectively copied the entire contents of data from my local computer to the server. So the next thing we want to do is do the opposite. So we demonstrated one way, one direction from my local computer to the server, and now let's try from the server to my local computer. So the command is of course very similar. So I'm going to go back to my local computer. So I'm going to operate from my local computer. I'm going to clear this up with Ctrl L, press the arrow up to recover a command that is similar to what I want to do. And now I want to reverse the order of things. So now let's say that I want to copy the data that exists already at the server under the directory tmp. So we already have that data, we already saw it. And now what I want to do is the opposite. So I copy from the server, that's the source, and now I can choose any other destination. Just to make things clear, I'm going to copy the data back, not to the same location where it was stored in the beginning, but I'm not going to do like the round trip. I'm going to copy it somewhere else so we can admire it somewhere else. So where, let's say downloads, let's try that. Downloads is a folder where it's very common to put stuff that you bring from the outer world, from the internet. So let's do that. So now the command hopefully makes more sense. So we are copying things in a secure way, so scopy, because we're going to copy not just one file but an entire directory. We need to call recursively. We're going to be acting as the root user on the server. The address of the server is this one here, and the location of the data that we want to copy is at temp/data. So this is the source of the data, and the destination is going to be the home directory of my local computer at the downloads directory. So let's run that, and let's admire the process. So with this, we have learned how to move data from my local computer to the cloud, and from the cloud to my local computer. And the requirement, remember, it was that we have a connection via SSH. So that's what makes the connection secure. That means that if the traffic that I'm sending from my computer to the cloud or from the cloud to my computer is intercepted by a hacker, the data is still safe because it travels in an encrypted way. That is what SSH does. It gives security to the transfer of data. All right, so let's now talk about another way of moving data, or like from different sources and destinations. So now I'm gonna be talking about the idea of moving data between a server, like the one that we had like a moment ago, and a container. So actually, because I do have a terminal on a server running, this one here, this one is on the server, I'm gonna use this terminal here. So this command I don't need to run because I already ran it before. So we're going to be using the volumes. So if you need to know more about volumes, here's a link to learn more. Docker actually recommends volume as the preferred way to share data between containers. And volumes come in two flavors. One is the idea of basically mapping one place in your computer. In this case, it's going to be, when I talk about the host computer here, it's going to be a Droplet running on Digitalocean. And when I talk about a server of that computer, in this case, it's going to be the container running on that server, which is a very common pattern, right, of running containers inside cloud computers. So the volumes come in two flavors. One where you have to specify which is the location in the host computer that maps to a location in the server computer, in this case in the container. But the other flavor is one where you only say where the folder will live in the container, but you don't specify any location on the host. You just say a name, so it's just a name for that directory that is going to be managed entirely by Docker. So you don't need to know where the data is going to land, because Docker will know for you. So this is the idea of delegating the responsibility of managing the location of that directory to Docker. That way, the data is more portable. You can share that data across containers regardless of the file system structure of the host computer. If this is a lot of jargon, it is. It's true. But if at some point this comes in as something useful, then I recommend you to read the link here about volumes, because it's a very powerful idea, the idea of abstracting the actual file system of the host computer, not needing to know where it is. Okay, so the next thing I'm going to do is I'm going to run this container. So I'm going to explain what it does and then actually run it. So we did something like this many times throughout this series, and if you need to know more about Docker in general, I recommend the series about Docker at ds.docker, at 2 Degrees Invest Initiative. So you can find that series and learn more about this. Here I'm going to go real fast. So basically I'm asking Docker to run a container. I'm going to call it with a name. It's going to be called my container. I'm going to detach the output from the terminal that is going to run this command, so I can use that terminal for other things. And it's going to be, the container is going to die when I stop that container, so I don't need to do any cleanup. And I'm going to create two volumes. Basically, the first one is going to be a volume managed by Docker, where I don't say the location of the host computer, I just say the name of that volume. And I do say where I want that volume to land in the container. So I want it in the home directory of the container. I know a lot about this container, and the home directory of this container is Home RStudio. So there is where I'm going to put that volume managed by Docker. Then I'm going to create another volume just to compare this different type of volume. It's called a bind mount. Basically, I have to explicitly say where in the host computer that volume lives. In this case, it's going to live under the root, directly at the root of the, that's why there is a slash here, at the root of the system and the folder is going to be called bind mount. That's the name that Docker gives to this type of containers. And where is it going to land on the container? Well, also on the home directory of that container, home RStudio, and the name is going to be, of course, bind mount to make things easier. Then this particular container, Rockerverse, requires a few other things. It requires a password, it requires a place, an address where I want to find it, and I'm going to give it root privileges so I can do just about anything with it. And I'm going to show you how that's useful in a moment. Okay, so that was a lot. Again, if you are new to Docker, this will be a lot to digest, but for now, because Docker is not the focus of it, but actually the idea of using Docker volumes, let's just run it. So let me clear this up with Ctrl-L and now paste what I copied from there. This should now give me a Docker container running. So if I do, let me clear this up again. If I do a Docker PS, you will see that there is this my container already running. So how can I access it? Well, I mapped it to the port 8787, and I can find it also at, where is it here? Actually, before I go there, I wanted to show you, before I go to I log into RStudio, because that Rockerverse image runs RStudio. Before I do that, I want to show you that Docker volume. So Docker volume is a command that allows you to manage volumes. So if I do Docker volume ls to list the volumes, you see now that named Docker volume that we don't know where it lives, we just know that Docker is going to manage it, already exists, is there. And also if I do an ls on the root, remember that we mapped and we created another volume called bind mount at the root of this system. So running this command and getting no output means that the directory exists, but it's empty. So if I do an ls on root, you see that that bind mount volume exists. So we successfully created these two volumes, which will allow us to share data between the container and the server and between two containers. One is here, I'm highlighting it right now, it's bind mount, and it exists at the root of the system of the server. And the other one exists in somewhere in the world where Docker manages it. We don't need to know where it lives. But now we're going to look at those two volumes inside the container that is running. So let's do just that now. So for that, I'm going to create, I'm going to open another window here, and I'm going to paste this address. So this is the address where I can find the container running. Of course, it has that number that I have been talking about a lot, and also has the 8787 magic number that comes from that call from here, basically. Right. So I'm gonna open a new window. I want it to be a private window. I don't know why. It has to be somewhere. Yes, here. So I'm gonna paste that there. This gives me an interface to log into RStudio. I'm going to put the password that I chose for myself. And in the meantime, I acknowledge Linda that it's 8:22 on my computer. So I think I should be able to demonstrate the rest of the meetup. Maybe remind me if I'm when I'm very close to 1/2 So I'm already logged in to the container Rockerverse from Rockerverse, and you already see here on my, let me make this a little bigger. You can already see on my home directory that I have these two volumes that I created when this container was run. So I'm interested now in working only with the terminal. So I'm going to click here on the terminal tab. And let's move this here to the left, to the right, and let's move my notes here to the left so I remember what I wanted to show you. And here is where we are. Okay, so the first thing I wanted to show you is that, basically that this, these two volumes already exist. And now I'm gonna try kind of share data between the container and the server between the container and the host of this container. So, for example, I will. The first thing I want to try to do will fail. So I'm gonna try to create a new file with the command touch, It's going to be inside the bind mount directory, and let's call it a.csv. If I try and run that, it will fail because that directory is, is kind of restricted in the privileges. Who can write to it? Only the root could write it. So I could hack that with the sudo command. When I run this container, I use an environment variable called root equals to true that allows me to run sudo. So if I do that, then it will work. So if I do an ls now on bind mount, you will see that the a.csv file exists there. But that's kind of painful because I should do this for every single file that I want to copy inside that, and it makes no sense because where am I? I'm at the home directory of this user. So this user should have privileges to add files inside its home directory, right? So we can fix that in a general way using this command. So what we're gonna do is basically use sudo to act as the administrator only once, and then just change the ownership, chown, change the ownership of anything recursively inside home RStudio. And we have to say, okay, who is going to own this? And the trick is this. So in this case, the user that we are now is called RStudio. So, and we need to call it like this, RStudio, because RStudio is actually two things. It's a group and it's also a user. It doesn't matter if you don't understand what this is. Actually, here I committed a typo, RStudio. But if at some point you need this, you will find this, hopefully this meetup useful. So with this, I'm changing the ownership of anything that is inside the home directory of the user RStudio, so that the user RStudio can do anything with it. So that means that if I now rerun that command that I did before, like touch bind mount /acsv, I don't need sudo to do that anymore. And the same thing would work for the other volume, for the one that is managed by Docker, volume managed by Docker, if I create another file, say b.csv. So that's the trick. If you find yourself that you do have privileges to work as an administrator, but when you want to save files, you get that permission denied, you may just want to change the ownership of the entire, recursively of your entire home directory so that you can do anything with directories that live there. All right, so now let's enjoy, let's kind of demonstrate that we are actually sharing data. So I have added files inside the container, but what we want is to see those files now outside the container on the server. Is that true? Okay, let's go back to a terminal that is running on that server, which is here. And now let's do an ls on bind mount, and we see already that file a.csv. So you can see that we could use that bind mount type of volume to share data between a container and a server. And if I touch another file here, for example, from the server, let's type touch c.csv. I'm creating a new file now on the server, and I want to see if that makes it all the way to the container. So let's do now an ls here on bind mount. Yes, Linda. Very close to the end, right? Thank you. Okay, so right now I have demonstrated that the opposite is also true. I can create a file inside that server and make it appear on the container. So right, the root goes both ways. The very last thing I would like to show is this idea of, okay, so now how do we use that other file that we created in the volume that is managed by Docker, that file called bcsv, for example. What if we want to share it with another container? How could we do that? All right, the trick is to create a new container. So let me show you that. So in this kind of volumes, it's suitable for situations where you don't need actually to know the actual location, but despite that, you can access the data that lives in one container from another container. So let's do that now. So I'm going to create another container. I'm going to type this. Let me break it down for you. Let me make this bigger. So I'm here on the server, and I'm about to run another Docker container. I'm going to remove it also when it's done. And it's a different kind of container. It's a lot simpler. It's going to be a TI means interactive. And I'm going to do exactly the same thing that I did before, create a volume. But in this case, the volume already exists. So because the volume already exists somewhere in the space that is managed by Docker, that volume will actually, with its contents, populate the new container. So that's the way that we use to kind of move data from one container to the other. And in this particular case, I'm not going to map it to Home RStudio. I'm going to just put it at the root of that new container. And the system that I'm going to be running here only runs bash. So let me run that there. Now I am in a container. It doesn't look very flashy as it does the interface of RStudio server, but this is it. So let me clear this up. This is a container running inside my server, and if I do now an ls, you can see that that volume is there. And now what you would expect, if I do an ls on that directory, you should see the files that we added in the other container. So let me wrap this up. What did we do? In this very last example, we created some data in one container, and now we are making it accessible in another container, right? So that was the idea of sharing data between containers, in this case, never going through the kind of the server itself, other than by storing it in a space that is managed by Docker. All right, so that's the end. I'm going to go back to your faces and do a super quick wrap up to mention once again what we did and open the floor for questions. So what we did is we talked about common ways of sharing data between your local computer and a remote computer. In this case, using as an example, a server on Digitalocean. And then we also saw a couple of ways to share data between your Droplet on Digitalocean and containers running in it. First, we did it directly from one, using bind mounts type of volumes that map a location in the Digitalocean Droplet to the container. And then we also did it with the other type of volumes, which is managed volume, a volume managed by Docker, which location we don't need to know, but allows us to share data between containers in a very portable way. All right, I'm sure there is a ton of questions in your heads, but maybe they're so complex that it might be hard to articulate. So any comment, question here before we go? Good. This has been an extremely technical meetup. Acknowledge that. That's probably the reason why we don't have so many questions. But it does respond to an issue that we faced with Linda when we were working with containers and basically creating data inside a container that we wanted out. And many times we got that permission denied thing, which motivated me to investigate a bit more how to kind of fix that problem for once. And for good. So yeah, I wanted to capture that in a meetup, and I think this might be the last meetup of this series, or maybe not. There is one more topic that I may need to cover for the next meetup. Otherwise, we'll be changing topics very soon. Thank you very much for joining. See you next time.